All right, we all love application problems, but before you complain about it, let's make sure we understand why we do them. Okay. With word problems, we are given information, and it's our job to turn that into an algebraic expression or an equation, because once we are in algebra, we have rules that we can follow. We have procedures. If it's an equation, we know it's something that we can solve. We get answers from the algebra, and then we take those answers and we interpret them based on what the question was asking. So here we're talking about a corn maze, and we want to find how many of each kind of ticket were sold. That means how many adults and how many children. So the end result is going to be, oh, there were so many adults, so many children, and that's it. This is a great example of a system of equations, how you want to use that. Because we have two things we don't know. We don't know the number of adults and the number of children. So when you're doing this, define your variables in a very smart way. So if we let A equal the number of adults, and then we'll let C equal the number of children. Pick variables that make sense. I mean, you could use X and Y. I'm going to use A and C because whenever I see the variables or see the letters A and C, my mind is going to connect that to adults and children. It's going to make the problem a whole lot easier to understand. So with a lot of these questions, and this is not going to be true for everything, but a lot of times there's going to be just an equation that deals with counting the number of things, and then another one that connects a value to each of those things, a unit cost. So we have here that there were 130 visitors total. Okay, that's going to be some adults and some children, which means that total number of visitors, the number of adults, plus the number of children would equal 130. It's the same as saying 130 tickets, 130 people, each one has a ticket. There you go. But the next part deals with the value. How much was each adult charged? Well, the unit cost for an adult was $10. So that's going to be $10 times the number of adults would tell you how much revenue you get from selling adult tickets. And similarly for the children, that's $7 per child. And the total revenue is not 130. The total revenue is given to us as $1,063. That is our total revenue. So we have these two equations. We have two unknowns. Let's solve this. Now, for me, I'm the kind of person that, I tend to go to elimination method, especially when the equations are set up like this, where they're both in standard form. So I'm going to take this first equation and multiply times, what do you think? A negative? That's good, that's good. Negative what, though? See, I'm going to use -7. That's going to cancel out the C. You could use a -10 to cancel out the A. It's still going to be the same at the end. All right, so when I do this, my first equation becomes -7A minus 7C equals -7 times 13 is 91, so 910. And then we have 10A plus 7C equals 1063. And we did this so that the C's would cancel out, giving us 3A equals, so 1063 minus 910 is 153. And if we divide both sides by the coefficient for A, we end up with 51. And if A is 51, we know that the sum is going to be 130. So that means that C is going to be 130 minus 51, and that equals 79. I think that's right. I know I've got a calculator, so probably check. All right, fine. You know what? I'm going to check. Does that make you happy? Sure. So 51 plus 79 equals 130. Great. Look at your second equation. So if you look at the adults and children, so we have 51 adults at $10 a ticket. So that means that we were taking in $510 in revenue just from the adults. For the children, that's going to be 79 children times $7 per ticket. So that's $5.53. And when these guys are combined, there is your $1,063 total. Again, you may not believe me, so let's check with the calculator. 51 times 10 plus 79 times 7. 1,063. Now, just because we have answers doesn't mean that we're done. We went to algebra so that we could work the problem and we could come up with an answer. But we have to interpret that in the, in the realm of the problem. How many of each type of ticket were sold? All right, well, we can say they sold 51 adult tickets, 51 adult tickets, and 79, 79 children's tickets. So there you go. Systems of equations working for us, not against us.